Hello guys, welcome to my series of videos looking at this is the Edexcel course, core 1 of AS level mathematics. So today I'm going to be looking through some of the MyMaths lessons and talking you through exactly what things are. Now we're going to start today with surds, and I think we're going to work through surds as far as I can by looking through the lessons on MyMaths. So if we get straight on, um, so I don't really understand what this first bit has to do with surds, so I'm just going to leave this bit and I'm going to go straight to number 2, where we're just going to start looking through some of the basic surd rules. So now I'm just going to basically just go through the entire lesson and hopefully you will learn a bit about the simple sorts of bits of surds. Okay, so surds have their own sets of rules. These you need to learn, they're not going to be given in the exam. So on your calculator, please work out the value of root 4 times root 9. Now, you shouldn't really need a calculator for this because basically all it's asking you to do is forget the fact that there are roots there and just make sure you put a root in your answer. So therefore, you want to do 4 times 9, but we can quite literally just put this into a calculator. As it says, you can use a calculator. I'm going to make use of it. So if I do 4 times 9, which is 36, so theoretically we could leave the answer as root 36. But root 36 is not a surd. It can be worked out as an integer. So if we square root 36, we'll actually get 6. And in order to check our answer, we can then do 6 squared, or 6 times 6, which should give us 36 again. So our actual answer is 6. So if we type 6 and click mark it, we then know that the answer is 6, or correct. Now it's saying 6 is the same as the square root of what number? So we've already worked this out because we kind of broke it down instead of just sticking root 4 times root 9 into our calculator and getting the answer 6. We actually know that the answer they're looking for is root 36 because we sort of had to go through there. So we're going to type root 36 and click mark it. So what is the link between the question and the answer? Now they might be thinking of a different link because they haven't done this in a while. But the link I see is that if you forget the roots are there, then 4 times 9 equals 36, and you're just sticking roots on top of all of them. So that's it next. And it's saying here we have the rule, which is root 4 times root 9 is equal to root 4 times 9. You can just stick them all under root signs. That works for when you are timesing roots and when you are dividing roots. It does not, I repeat, not work when you are adding or subtracting roots. So therefore, root 4 times root 9 is equal to root 4 times 9, which is equal to root 36, which is therefore equal to 6. Moving on. So therefore, this leads us to our first rule for multiplying surds, which is the fact that root a times root b is equal to root ab, which is basically a times b. Moving on. Okay, a question about simplifying surds can mean several things. That's fine. Sometimes it can just be a case of combining two surds into one. So, for instance, root 5 times root 2 is simply root 5 times 2, and 5 times 2 is 10, which is equal to root 10. So that's what that is. If the answer turns out to be a whole number, carry on and work it out. For instance, if you've got root 18 times root 2, which is root 18 times 2, and 18 times 2 is 36, so it's root 36, and as we know from the first bit, root 36 is equal to 6. But sometimes you can also work backwards. For instance, you can break 48 down into the product of 16 and 3. So root 48 is equal to root 16 times 3, which is also therefore equal to root 16 times root 3. 16 is a square number, so give root 16 as a whole number, which is basically where it comes to the simplification. Now we have broken the root 16 times 3 down into root 16 times root 3. Now the root 16 bit of it is a whole number, and so root 16 is 4. So we can actually break that down and use the normal number, but root 3 cannot. So the answer we leave is technically 4 times root 3. but we can actually dispense of the times sign and just say 4 root 3, which is how you might see a lot of surds, which is all that is. Take care, you must find the biggest possible square factor, otherwise your answer is not simplified to its full extent. 48 can also be written as 4 times 12, which would give you an answer of 2 root 12. For instance, if we look on the bottom right of the screen, it says here root 48 is equal to root 4 times root 12, which is equal to root 4 times root 12. And root 4 is 2, so the answer there is 2 root 12. Now, our aim is to leave the smallest possible number inside the square root, so this is not such a good answer, because it is the simplest way of doing it, because that's what we've done, and that's the way to do it, but you're not making it massively small. Okay, let's move on to number 3. Now, surds, now it just says they have new rules, so surds have their own sets of rules, these you will need to learn. Work out the value of root 100 over root 25. Now this works pretty much the same as the first rule by the fact that you can put them together. So if you imagine the root 100 divide sign root 25, you could actually just, it's the same as saying root 100 over 25 rather than saying root 100 over root 25, which is a bit annoying. And it also works with the same idea of if you forget about the roots, it's the same as 100 over 25 equals that, and stick a root on the answer. So 100 over 25 is equal to 4. Now, because it's a root, that means the answer is root 4, and root 4, as we know, is 2. So our answer there is 2. Now, 2 is the same as the square root of what number? Now, because I worked it out in the long way instead of using a calculator, we know that that is root 4. Mark it. So what is the link between the question and the answer? Now, as I've already mentioned, 100 over 25 is equal to 4, so root 100 over root 25 is equal to root 4. Which, as I've already explained, root 100 over root 25 is equal to root 100 over 25, which is equal to root 4, which is equal to 2. Which leads us to our rule for dividing surds. So, root A over root B is equal to root A over B. Now, this should be relatively easy to remember these. So, a question about simplifying surds can mean several things. I think this is sounding familiar. Sometimes it's just a case of combining two surds into one. For instance, root 10 over root 2 is equal to root 5, so 10 divided by 2 is 5, and stick roots on. If the answer turns out to be a whole number, you can carry on and work it out. So root 18 divided by root 2 is root 18 over 2, which is equal to root 9, which is also equal to 3. Now normally, if root 9 was an actual surd, rather than just a square root, you would leave it at root 9, but actually, because root 9 can be simplified to a whole number, we have to work out root 9, which is equal to 3. Now, again, you can also work backwards. Here we can square root the top and the bottom separately. So root 4 over 9 is equal to root 4 divided by root 9, which is equal to 2 over 3. Hope you understood that. Moving on. So surds have their own set of rules. Rule 3. These you will need to learn. Work out the value of root 49 squared. Now, root 49 is the opposite to 49 squared, if that makes sense. So the root and the squared cancel each other out completely. Now, root 49 squared, as you will probably be able to work out, is the same as root 49 times root 49, which cancel themselves out. So the answer we are left with is simply 49. I do believe I'm right. Now, this is a fairly obvious rule. If you square something that has just been square rooted, then you'll have what you started with. So our rule is basically a square root squared is equal to the original number, or a square root times the same square root is equal to that original number. Right, now simplify these surds. Please press R, which would be useful for me, to get a square root sign. No calculators allowed. Now then, I want to talk you through the first one. Now the first one is basically saying root 3 times root 5. Now they have just dispensed of the times sign. So if we just use my tactic of just forgetting about the root, so it's 3 times 5, which is 15, which which is root 15. So we can just leave it as root 15 like so. Now I'm not going to simplify it just in case I just spend ages simplifying it then finding out that I can't, so I look stupid on this video. And the same for this, it's literally 3 times 48. So if I put that in there, I get 144. So that could be left as root 144. Hold on one moment. There we go. And root 63, we now need to simplify that out. So you need to basically find two numbers where that times together where one of those numbers is a square root. Sorry, it's a square number in order to get the thingy. Now moving on to the root 8 squared, which using the rule, there's no real working out to do here, it's just 8. 66 divided by 6 is what we need to do on the second one, which is equal to 11, and because there's root signs it's root 11. 28 divided by 7, 28 divided by 7 is 4, I'm stick a root, so it's root 4. Now we obviously know that one is 2. And mark it now. It may say that those two are wrong, that's because that can be simplified. But I'm not going to do that now, you can obviously work out what that is. So work out the following sums, leave your answer in insert form. Now as I've already mentioned, the 2 root 3 and the 5 root 2, you can actually split those up. That's literally saying 2 times root 3 times 5 times root 2. Now, with timesing, you can times in any order. So you can quite literally do 2 times 5 times, so if you just reorder it, you can do 2 times 5 times root 3 times 2, which you can kind of just treat as two separate things. So you could do 2 times 5, which is 10, and root 3 times root 2, which is root 6. So basically it's 10 root 6. Now, this bottom one is, you literally have to do the same thing. It's dividing, I do think. But basically all you have to do is divide the numbers. It's relatively simple there. Oh, here we are. It's telling us how to do it. Actually, that's exactly what I did. It reordered it from 2 times 5 times root 3 times 2, which is nice and simple, which is equal to 10 times root 3 times 2, which is equal to 10 root 6. Okay, so now we just need to plonk these into the original thing, so it's 10 root 8 on the top over 2 root 4 on the bottom, which is that same as 10 over 2 times root 8 over 4. It's the same as doing the 2 is 5 root 2. Now you need to simplify those surds. Now I'm not going to bore you with that, I just want to go through the rules in this video. So let's skip this. Now let's have a look at this. So basically here are 8 pairs of surds, each pair has the same value. Can you match them all? So it's basically just a matching game. So if you have access to MyMaths, I do highly recommend you have a look through these. I'm not going to do them myself because really it's about you fiddling about, and that's not really me able to do that on the video. So let's skip this again. Now we can go through this because it should answer it for us. So root 27 minus 2 root 48 plus 3 root 108. Okay, this looks really nasty because there are 3 square roots. The key is spotting that 27, 40 and 100 all have a common factor. That's common factor of 3. So 27 is equal to 9 times 3, 48 is equal to 16 times 3, and 108 is equal to 36 times 3. Now, miraculously, the other factor in each pair is a square number. So we can square each of those to get our answer. So you can rewrite the expression using these factors. So this equals root 9 times 3 minus 2 root 16 times 3 plus 3 root 36 times 3. Which can then be break each square root into 2 parts. So open brackets, well, you can read that. Oh, I've gone too far, but fine. Which is equal to that, and you'll use to collect the like terms. So basically, the final answer is 13 root 3. So, that is surds part 1. Now, I do hope you enjoyed my explanation. Now, the reason I really wanted to do these explanations is I have tried to do MyMaths before, and I've never found that just reading something, it doesn't really go into the brain, and I like it when people explain it. So I thought I would literally just read it out, which is really all I've done. So anyway, I hope to see you in the next one. Now, for any Apple geeks out there, you may have noticed that I am running OS X Yosemite, and then if you are really Apple geeky, you will have noticed that on the 16th of September 2014, OS X Yosemite has not been released to the public as of yet. So you can work out how I've got it if you really want to, but you don't have to. Anyway, I'll see you guys later.